Are you ready? All right, so let's look at P2. I can find the correct notebook. All right, so P-2. I didn't happen to write down the name of this section. Oh yeah, I did. I lied. Cartesian coordinate system. I said I lie all the time. Cartesian coordinate systems. I know. Don't ever trust the word I say. Nothing. Look at you bringing your own little glass with eyes. Crack me up. No, don't you judge me. I lost my big ruler. Okay. So let's just briefly talk about the coordinate graph. This is all stuff that you should know from Algebra 1, 2, and Algebra 3, 4. So your axes, this is your x-axis, this is your y-axis. This point right here is 0, 0, also known as the origin. Then we have quadrants. This is the very first quadrant you ever learned to graph in, so that's quadrant 1. Is quadrant 2 in the upper right or the lower right? Oh, sorry, upper left or the lower right? I was trying to trick you. Because neither one of those originals is the answer. So you want to go counterclockwise to name your quadrant. So this is quadrant 2, quadrant 3, quadrant 4. In my world, and so that's code for on my test, you must name quadrants with Roman numerals. However, with MathXL, I believe they actually use numbers 1, 2, 3, 4. So please make yourself a mental note. Don't use numbers 1, 2, 3, 4 with me, use Roman numerals because that is your typical proper way of naming a quadrant.
So we lose points on the
Yes, you would. It would be code 4. We didn't take proper notes on Mrs. Murray's strange preferences. Quadrant 1 is a positive quadrant because it is bordered by positives, two positives, axes. So what is the sign of quadrant 2? It's bordered by a positive and a negative. What's positive times negative? Negative. And so that's why that's a negative quadrant. What's quadrant 3? It's actually positive because it's bordered by a negative and a negative. What's a negative times a negative? Positive. And so quadrant 4 is a negative quadrant, bordered by a positive and a negative. If you think about it, it makes sense that the negative quadrants are diagonal to each other because if I have a negatively sloped line, both ends of that line, which are infinite, right, are going to end up in the negative quadrants. If I have a positively sloped line, both ends of that line will end up in the positive quadrants. No matter that part of the line passes through a negative quadrant, it's the ends of the lines that actually make it a positive line. Yes. Because it's just not done that way. You have an overall sign for a quadrant. And the signs really help you refer to whether your lines, when we talk about linear lines, are positively or negatively. Then, for some of you, this is really basic, but I'm putting it in here just in case somebody doesn't know it. So, we graph ordered pairs in here, and you're going to have to identify ordered pairs in your homework tonight. X comes before Y, right? So you always go right, left first, and then up or down. It's just the opposite of plotting the slope of a line. And we always start from the origin. So if I wanted you to plot the point A at -3, +4, I want you to plot that point and tell me what quadrant it is in. So label that point A in the graph and also figure out what quadrant that belongs in. Allie? So if we go to the left, 1, 2, 3, and up, 1, 2, 3, 4, this is where point A is, and Allie is correct. It is in quadrant, which is a 2. Now plot the point is the only other point we'll do. Plot the point. Plot the point B as in boy at 0, -6, and tell me what quadrant that is in. So 0 means we don't go right or left. -6 means we go down 6. So this is point B. It is in no quadrant because it's on the fence, so you are correct. So you can name it a couple of ways. I like to say that it's on the y-axis. Math Excel is going to say, I think they'll give you a choice of on the y-axis with quadrant 3 to the left and quadrant 4 to the right, or a positive quadrant on the left and a negative quadrant on the right. They kind of describe it a little interesting because if you were up here, if you went the wrong direction, then you would have these two quadrants, and so that's why they're asking that question. Yes, it's on the y-axis, but exactly where? It's in between quadrant 3 and 4. So you have to know your quadrant system. Alright, so enough about that. Let's evaluate. So example 1. You will evaluate. This is a really difficult question. Absolute value of -4 equals what? 4. What does absolute value mean? Very good. The distance a number is from 0 on the number line. So what is the absolute value of positive 4? 4. So if I ask you what does absolute value mean, your answer is not, well, it's always positive. That's what it is. What it means is what you just said, that it's the distance from 0 on the number line. Alright, what about this though? You have a question tonight related to this. The absolute value of pi minus 6. So you can take your handy dandy calculator and we could figure that out, because technically, if I found out what pi minus 6 was, I could take, you know where your pi button is on your calculator? It's right above the caret, and it's in blue, so you get to it with the second function key. So if I took second function caret, there's my pi, and I subtracted 6, I get a negative value. And let's just round to, I don't know, 2 decimal places. They'll tell you in Math Excel if they want you to round what 2. And so the absolute value of that would be a positive 2.86 because it's got an 8 next door, so it rounds up. But what they're going to ask you to do is rewrite it using pi. So technically, we just discovered that this was negative 2.86, which is, that's approximate, right? Which is approximately equal to positive 2.86 as an answer. But that's not the answer we want to get. So since it comes out to be negative, doesn't the value, if I took this out of the absolute value, the value of this turns out to be the opposite. That turns out to be negative, right? So to get the absolute value of that, don't we want it to be the opposite of that? Because I know that's going to come out to be negative because 6 is bigger than 3.14. Does that make sense? So I put a negative in front of it because I want the opposite sign. I want it to be positive. So that's how I took the absolute value signs away. Then if I distribute that negative, I get a negative pi plus 6. And imagine Math Excel would take that, but that's uncomfortable. I would write it as 6 minus pi. These are the same. So if you had to write that answer in exact form using pi, and by the way, hopefully you realize that there are tools to the left of your questions where pi would be. You've got to use their tools, otherwise they won't recognize certain things. then you must know your distance formula. There are two distance formulas, one for the number line and one for the coordinate grid. I won't give you the distance formula. You need to know it. So if you don't know it, learn it by Friday. The distance formula for the number line if I want to find the distance between two numbers on the number line, we just take the absolute value of the difference between the numbers. But on the coordinate grid, it is distance is equal to the square root of, and there's a variety of ways you could see this. You're essentially taking the difference between your y's and squaring them, the difference between your x's and squaring them, and adding those together to take the square root. So I choose to write it this way. Does it matter whether x of 2 comes before x of 1? No. You can have x of 1 minus x of 2. You can have the x's come before the y's. But essentially you're taking the difference of the y's, the difference of the x's, squaring them, adding that together, and then taking the square root. So that should be a familiar formula. In addition to that, the midpoint formula you'll need to know. I will not give this to you either. And there are also two midpoint formulas, one for the number line and one for the coordinate grid. So on the number line, you're going to take the two numbers, add them together, divide by 2. That'll get you the coordinates in between. And then in the coordinate grid, doesn't this essentially look like an average, by the way? Adding two things and dividing by 2, it's an average, right? Coordinate grid, same thing for your midpoint, so this is midpoint. Coordinate grid is going to be an ordered pair. So you take the x values, x of 1 plus x of 2, and divide that by 2, so you're averaging the x's. And then you take the y values, add them together, and divide by 2, so you're averaging the y values. Of course, paying attention to signs. So I'm going to give you a problem using these formulas, or several problems using these formulas I want you to work on. Got them? Flip it. I would just do it as part of your notes. So this is your next example, but I don't think I have to go through the example with you. I think you can do them on your own. Alright, so example 2, because this is a review. Find the distance between 1, 5, 1, 5, and 6, 2. They didn't give you any negatives. If I review, I would label these as x of 1, y sub 1, x sub 2, y sub 2, because your greatest error in finding distance is putting the x's and y's in the wrong spot. I also would suggest that you use a template when you're using any of these formulas. So I'm going to rewrite that formula that I just gave you, but without the x's and the y's. That way, and the reason why I do that is if you had negatives in here, a lot of times if I had a negative 6, you guys would just put a minus 6 instead of a minus 6. So if you get in the habit of using your formulas as templates and then input the values, you're likely to get the signs correct. Alright, so finish it up. Now you have to pay attention to your directions on your homework to see do they want the exact answer or do they want a rounded answer. Now if you reversed your numbers, you had the 5 first and the 2 second, the 1 first and the 6 second, your signs are going to be the reverse of mine. It doesn't matter because when we square those, we should all come out with 9 plus 25 there. Square root of 34 cannot be simplified, so that would be the correct exact answer. But then if you plug it into your calculator and round to 2 decimal places, you get approximately, so it sort of equals 500. So we're good with that. All right. Example 3. Find the midpoint of the line segments with endpoints -9 and +3 on a number line. So you're using the number line formula. And again, if I were you, I'd be using a template. So once you identify, you're supposed to know it. That's what your template looks like. Here's the weather advisory. Beware, it looks like a storm out there. I got mad one time when all those were going off and I didn't understand. Because I didn't have that click on my phone. I'm like, why is your alarm going off? And then all the classes come on. And then bless your little students' heart, she explained everything. What'd you get? And is -3 in between -9 and +3? So it's a reasonable answer. You could obviously plot them and check to make sure, but they are indeed, that is indeed the good point. So, example 4. Find the midpoint of the line segment with endpoints -5, 2, and 3, 7. So again, I would emphasize that you use the template. And I would emphasize that you label these as x1, y1, x2, y2. And force yourself to think which ones are the x's, which ones are the y's. What'd you get? X value. What is it? -1. What's the y value? Yeah, don't go decimal. You both like decimal. 4.5 or 9/2. 4.5 is reasonable for plotting a point. And then you could plot those points in the coordinate grid. That point should be directly in between them if you wanted to check it. Alright, then we're going to move on to circles. So the standard equation for a circle I don't know why you guys have trouble with these, because it's probably the easiest equation of all. Other than maybe it's a study issue, I'm not sure, but some of you really seem to struggle with this. So, make sure that you know what you're doing. X minus h squared plus y minus k squared equals r squared, where hk equals the center and r equals the radius. So if you take the square root of this, you'll have the radius. And then notice that hk is the opposite signs of here. This is negative h and negative k. So if you take the opposite signs of the numbers that are being added or subtracted to y, that becomes the center of the circle. So you have to be able to go forwards and backwards with this. We've got several questions that have you do that. So, example 5. Write small. Do down here at the bottom. Find the standard form. Equation of the circle. So A, you got a center that is negative 4, positive 1, and a radius that is 8. So take the template. Use your template. So I have I've got x minus something squared plus y minus something squared equals something squared. I took out the h, the k, and the r because the y and the x should stay here. You should not be substituting for y or x. And then this is my h, this is my k, and this is my r. So if I substitute in negative 4, and h comes before k, x comes before y, so that's how you can remember what order to put them in. So the negative 4 goes here, positive 1 here, and 8 here. So your final standard form, what happens here? Yeah, so you get x plus 4 squared plus, nothing happens here, y minus 1 squared equals, you have to square the 8, 64. That's it. So could you have skipped that work? Yes, but some of you get your sign wrong. Part B, center 0, 0, radius is 5. So do that one on your own. And your answer should be x squared plus y squared equals 25. Yes. No, because x plus y quantity squared is not the same as x squared plus y squared. Because that would actually be the relation. Good question. Okay. So last easy question, and we have one more kind of detailed question, and then we're done. So example 6. Use an inequality to express the following distance. The distance between x and -3 is less than 9. So that appears to be the distance between 2 points on a number line, doesn't it? Because it's not over pairs. So isn't the template for distance on a number line, doesn't it look like that? So the distance between is what I'm using that for. Then the two numbers are x and -3. So I'm going to put an x in here and a -3 in here. And then less than is just your less than symbol. And then, of course, 9. Just symbol 9. So how would you write your final answer? Absolute value of x plus 3, you have to change the double negatives, is less than 9. That's all they want. Don't have to solve it. Just write it. Last question is a little bit more involved, and you do have a question just like this in your homework tonight. So it's one reason why I wanted to make sure that it was on here. So example 7. Use the converse of the Pythagorean theorem and the distance formula to prove that the points -3, 4, 1, 0, and 5, 4 make a right triangle. So the important part of a right triangle, we're going to use Pythagorean theorem and distance formula. Well, we're going to first find the distance of the sides of this triangle, and then throw in Pythagorean's theorem, a squared plus b squared equals c squared. Because they're asking you to prove it that way. There's other ways that you can prove it, but that's what they're asking you to prove it. So the very first thing I would do if I were you would be to plot those points. So I'm going to plot them off here to the side. And I'm going to label them as I plot them. So -3, 4 is here. 1, 0 is here. And 5, 4. Connect those with a triangle. So you visually cannot look at it and go, oh yeah, that's a right triangle. And I'm just going to name the sides side A, side B, and side C. Just for note purposes. Before I can use Pythagorean's theorem, I have to know the distances of each of those sides. So step 1 is find the distance of each side. the distance formula at least twice. Do I have to use it for this one? Can't I count squares on this one? Well, I'm not going to use the distance formula on a horizontal or a vertical line, because you can just count distances there. It's when your lines are diagonal that you have to use the distance formula. So I'm going to find the distance of A. So here's my formula. I'm going to use my template. I'm going to plug in my values. So my y's are 4 and 0. My x's are negative 3 and 1. I end up with 4 squared plus, add the opposite here, I get a negative 3 plus a negative 1, so I get a negative 4 squared, which gives me 16 plus 16, which equals square root of 32. If I were you, leave it unsimplified, because they're not asking you for the length of the sides. Leave it unsimplified. It's much easier to work with. So there's the length of side A. Then I'm going to find the length of side B. So the distance of side B right here. I'm going to put my y's in. So my y's are 4 and 0. My x's are 5 and 1. So I get 4 squared plus 5 minus 1 is 4, 4 squared, which equals 16 plus 16, which equals the square root of 32. So far I have an isosceles triangle, don't I? You also have to prove something's an isosceles triangle. This is one way to prove that two sides are equal. Right there I can say that. But we're looking to see that it's a right triangle. So then the distance of side C, I'm just going to count. How far is negative 3 and positive 5 from each other? 8, right? So then step 2, use Pythagorean's theorem. So it's a squared plus b squared equals c squared, and it's just a coincidence that this is, C should be your biggest side. Well, these are both in radicals, this is not. If this were in radical form, so let's say the answer to my square roots was 8. So what would have been under the square root? 64. Do you see how I know that this is the bigger side out of the 3? The bigger side has to go in C. So, looking at everything in terms of radicals, I know that that would have been the square root of 64. So I'm going to put in parentheses for my substitution. And for A, we're putting in the square root of 32. For B, the square root of 32. But for C, we're not putting in the square root of 64. We're putting in its actual distance, which is 8. We could put in the square root of 64 to get the same answer. So when I square a radical, don't I get the number underneath the radical? 32 plus 32 equals, what's 8 squared? 64. 32 plus 32 is 64. Doesn't 64 equal 64? Isn't that a check? What can you conclude? Therefore, the triangle is a right triangle. Why? Because that becomes true. It's true. Okay. So at this point, I'm going to attempt to answer some of your questions. Oh, looky, we can see my face.